Hey, Algebra 2 students. So now we're going to move forward to applications of quadratic functions. Now that you know about vertex form and standard form. So in this video, I'm going to cover just one type of application of quadratic functions. It's known as objects in free fall, or sometimes referred to as projectile motion, where things that are launched or things that are dropped follow the path of a parabola. When you throw a ball in the air, it follows a parabolic path until it hits the ground. It turns out that there's a function for projectile motion that is quadratic. Y equals negative 16x squared plus v sub 0 x plus h subscript 0. Now, the negative 16 always being the coefficient, you'd have to ask a physics teacher. It's got something to do with gravity being 32 feet per second, and you take half of that. But anyway, I'll leave that to them. This can be used to model the height, y, of any object in free fall after x seconds. V subscript 0 is the initial velocity, and h subscript 0 is the initial height. So if we read this first example, a ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. So you'll notice that the 40-foot high building is the initial height, so that's h subscript 0. At a speed of 80 feet per second, that's the initial velocity. So very, very quickly, we have y equals negative 16x squared plus 80x, substituting the velocity, plus 40. This quadratic function describes the path of the ball. So let's think about this. We've got our y-axis that's going to represent height, and we've got our x-axis that's going to represent time. So when we say that the ball had an initial height of 40, that means you're standing on the top of a 40-foot building, and then you throw the ball up in the air, and then it falls back down to the ground. So that's what the path of the ball looks like over time. A typical question that you're asked is, what is the maximum height that the ball reaches, and how many seconds did it take the ball to reach that maximum height? Well, I don't know about you, but this parabola has a vertex with an x and y coordinate. The y coordinate would be the maximum height, and the x coordinate would be the time it took to reach that maximum height. So whenever you read the question that says what was the maximum height that the ball reaches, that means we're wanting you to find the vertex. Well, h is equal to negative b over 2a. So if I take that to mean negative 80 over 2 times negative 16, that's negative 80 divided by negative 32, and comes out of a calculator as 2.5. K, the y-coordinate of the vertex, is found by plugging in h. So negative 16 times 2.5 squared plus 80 times 2.5 plus 40. Well, let me grab my calculator and punch this in. Sorry, I haven't done that yet. So let's see. Negative 16 times 2.5 quantity squared plus 80 times 2.5 plus 40 comes out of my calculator as 140. So this vertex is 2.5 comma 140. So, yeah.
Are you in a meeting?
No, I'm just making a recording.
What's that?
No, what you need? You want to come in and work? Come in and work, yeah. Okay, so what we know is that the maximum height is 140, and it took 2.5 seconds to get to that height. Okay, the next question is, how many seconds does it take for the ball to hit the ground? So they're asking us to find this point where the ball hits the ground. Well, that's an x-intercept. So we're being asked to find this x-intercept. How do we find x-intercepts? We let y equal 0. So 0 equals negative 16x squared plus 80x plus 40. Well, you have all the choices you've ever had that you can use to solve this equation for x. I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c. All of that over 2a. Okay? Well, I'm just going to crunch this out and tell you what the answers are. So we have 80 squared minus 4 times negative 16 times 40 is 8,960, and I need the square root of that. So here's where I'm at now. Negative 80 plus and minus 94.66 over negative 32. So we're going to get two answers. Negative 80 plus 94.66 divided by negative 32 is negative 0.45. And if we finally take negative 80 minus 94.66 divided by negative 32, we get 5.46.
Am I allowed to just put my stuff in here, Mr. Galvin?
You're fine. Okay, so there's an x-intercept at negative 0.45. So I want you to imagine right here, there could be an x-intercept at negative 0.45, and this x-intercept is 5.46, comma 0. Well, of course, this x-intercept is irrelevant in the context of the problem. The ball only flew from the original height of 40 feet up to the vertex and back down. So 5.46 seconds is how long it took for the ball to hit the ground. After how many seconds will the ball have a height of 50 feet? Well, does that say to let y equal 50? So then we have 50 equals negative 16x squared plus 80x plus 40. I could subtract 50 from both sides. 0 equals negative 16x squared plus 80x minus 10. Well, if I use the quadratic formula, x equals negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times negative 10 divided by 2 times negative 16. Well, let's see what's under that square root. 80 squared minus 4 times negative 16 times negative 10 is 5760. So now I have negative 80 plus and minus the square root of 5,760 over negative 32. The square root of that is 75.9. So now I have negative 80 plus minus 75.9, sorry about that, 75.9 over negative 32. So we're going to get two answers. We have negative 80 minus 75.9 and divide that by negative 32, and you get 4.87 seconds. And if you take negative 80 plus 75.9 divided by negative 32, you get 0.13. So is it possible that the ball could be at a height of 50 feet twice? Well, let's go back up to the picture. If you start at 40 feet and throw the ball into the air, here's say 50 feet. Well, as you can see, a horizontal line at 50 touches the parabola twice. So at 0.13 seconds, the ball was at a height of 50 feet. And at 4.87 seconds before it hit the ground, it was back down to a height of 50 feet. So, as you can see, this is an interesting physics application of quadratic functions, but it takes nothing more than being able to find a vertex and an x-intercept and solve other quadratic equations. So hopefully this will help you with the first 3 problems on the handout. So make sure you do problems 1, 2, and 3.